Hello, I'm Doug Watches. Welcome to the Locksmith DVD training program. In this course, we're going to again be looking at high security locks. The main purpose of this course is to make you aware of a number of different high security locks and their features. Most of this course will be spent on Mul-T-Lock. We will also talk about the ASA Twin, Obloy Protect, and Bi-Lock, and one of the first high security locks, the M-Heart. In this course, I will also take a few minutes to talk about the ASA Obloy Click technology, which has been integrated into the Medico, the ASA, the Obloy, and Mul-T-Lock high security locks. In case you are wondering about the Schlage Primus, that will be covered in the next course. Course number 20 will be devoted entirely to Schlage mechanical locks. In that course, we will cover many of the Schlage locks, including their high security locks, the Everest 29, the Primus, and the Primus XP. The first lock we are going to take a look at before we jump into Mul-T-Lock is the lock made by Corbin Russwin with the brand name of M-Heart. The M-Heart has some features that are similar to Medico, which we looked at in the last course, and it just makes sense to look at it next. As you learn about more high security locks, you will see similarities, as many locks belong to the same corporate family and are allowed to share in the technologies. Therefore, I would like to suggest that as you learn about new locks, try to answer three basic questions. What are the similarities and differences? What components do the locks contain? How does the lock function? The main goal of this course is to give you enough information that you will be comfortable beginning work on the new locks which are covered. We will not have time to cover every feature of every lock. In particular, we will not be able to cover master keying for each lock in detail, nor how to cut the keys. Most of the high security locks do require their own pin kits, and many of them require special key machines to cut the keys. Once you decide which locks you want to be able to service, you will need to get all of the service manuals for those locks and study them thoroughly. One of the things I like about the Schlage high security locks, which as I said will be covered in the next course, is that they can pretty much be serviced and master keyed with equipment you already have. Even if you don't plan to provide full service for any of the locks in this course, you still need to be familiar with them, as you will come across most of them sooner or later. Also, I am not going to try to pick any of these high security locks. Some of them can be picked, but it often takes special tools and quite a bit of time. Even with the right tools, the locks may not pick open. Therefore, in the case of a lockout, I suggest you look for an alternate way into the building. Remove the lock from the door and see if it's possible to shim the lock open. If that is not possible, just drill the lock. I demonstrated the drilling process in course 18 with the Medico lock. It is pretty much the same for other high security locks. Simply identify the location of the pins and/or sidebars and drill them. In the next course on Schlage locks, I will demonstrate shimming the Schlage Primus. This course is divided into 10 parts. Part 1, M-Heart's interlocking pin lock. Part 2, Mul-T-Lock's cylinder platforms. Part 3 will deal with Mul-T-Lock's classic lock. Part 4, Mul-T-Lock's interactive and interactive plus locks. Part 5 will deal with Mul-T-Lock's MT5 and MT5 plus locks. Part 6 will cover Mul-T-Lock's 7x7 lock. Part 7 will be Mul-T-Lock's integrator lock. And Part 8 will cover Mul-T-Lock's click technology. Part 9 will talk about other high security locks. And Part 10 will be review and practice. The course objectives include 1. Be able to explain the workings of the M-Heart interlocking pin lock. 2. Be able to explain Mul-T-Lock's cylinder platforms. 3. Be able to explain how Mul-T-Lock's telescoping pins work. 4. Be able to disassemble and reassemble Mul-T-Lock's classic, interactive, and MT5 locks. Number 5, be able to explain the feature of Mul-T-Lock's 7x7 lock. Objective 6, be able to explain the features of Mul-T-Lock's integrator lock. Number 7, be able to explain Mul-T-Lock's click or E-cylinder technology. Number 8, be able to explain the main features of the ASA Twin 6000 lock. Number 9, be able to explain the main features of the Obloy Protect lock. And then number 10, be able to explain the main features of the Bi-Lock. Number 11, be able to explain the main features of the Corbin-Russwin Pyramid Lock. The M-Heart is the first lock that we're going to look at in this course. The M-Heart's a high security pin tumbler lock. It's made by Corbin-Russwin, an old Connecticut-based company. The M-Heart is a 6-pin lock. It's best known for having interlocking pins. The bottom of the top pin and the top of the bottom pin have a T shape which interlocks. The bottom pins have a chisel point which allow the pins to be lifted and rotated, and the keys are cut at 20-degree angles to force the rotation. The pins have to be rotated to allow for the leg of the T on the top pin to line up with grooves in the plug, because when the plug turns, the legs of the T are still down below the conventional shear line, and the grooves in the cut into the plug will accommodate the legs of the T's. This lock was first produced in 1978. Became somewhat popular as the first economically priced high security lock. Corbin-Russwin has moved on to other high security locks, which we will look at later in the course. I don't come across too many of these M-Heart locks anymore, but I'm going to spend some time on this particular lock because I've noticed that a number of the certification tests still include questions about it. As you will see, many of the features of this lock are quite similar to the Medico lock we covered in course number 18. Medico did bring a lawsuit against Corbin-Russwin for patent violations and won the case, and Corbin-Russwin had to pay Medico royalties on each one of these locks that it sold up until March of 1987. Today, however, both Corbin-Russwin and Medico are owned by ASA Obloy. Has kind of a strange looking key. The cuts on the top look fairly normal, but these cuts are also angled, just like we saw in the Medico. These are cut at 20 degrees, 20-degree angle. This drawing shows the left cuts and the right cuts. If you hold the key with the bow to the left, if the cuts are basically coming right towards you, it would be a right cut, and then if they're going away from you, be a left cut. So that if you look at this cut here, the way I'm holding this here, it appears that this angle is coming right at me. So that would be a right cut. On this one here, on this cut right here on the end, the number 6 cut, it's going away from me, the way I'm holding it. So it would be a left cut. Another way to think about the key is if you were to take like an arrow with the point going towards you and line it up with the cut. So if it's pointing to the right, that'd be a right cut, and then if it's pointing to the left, it'd be a left cut. So either one of those techniques will work for identifying if they're left or right cuts. Now the manufacturer designates the left cuts with a number 1 and the right cuts with a number 2. So if you happen to see that as a designation, just remember 1 is left and 2 is right. And again, they only have the left and the right for the bottom pins, but the master pins do have a straight cut. They just call it same or S, but you have your left, your right, and then same for your master pins. That this part is not offset from this part, it's identical, whereas you see this one's to the right of the T leg and this one's to the left of the T leg. Here's a blow up of what the pins would look like in the Mul-T-Lock. You can see the bottom pin. This one has a master pin and a top pin. Again, they have this T-like shape where they interlock together. And for the lock to open, they have to have the leg of the T turned in such a way as to line up with a groove in the plug so that two pins can separate. With the master key, of course, then this one here would drop down to the shear line and turn so that it could open. Here's an exploded view of one of the Mul-T cylinders. You can see an enlargement here of the interlocking pins. This one has a master pin in it, so it's got a bottom pin, master pin, top pin. And you can see the plug with the grooves in it. In the drawing, you can see they indicate the grooves, clearance grooves for the top pins in the plug. With these locks are 437 rated, and again you'll see the hardened steel crescent in the front of the shell, and you're going to have hardened steel pins in the front of the plug to get the drill resistance you need for the 437 rating. And also in the drawing we can see that the grooves in the bottom of the key correlate with the grooves in the plug so that the key can be turned around and bypass the T part. The T part of this pin is going to stick down inside this area where the plug is. And so that's what necessitates having the grooves in the plug to allow for that little tailpiece as the lock opens. And that's what necessitates also the grooves in the bottom of the key so the key can come around and bypass those same pieces on the top pins. As we go through these different high security locks, you're going to start to recognize that many of them have similar features or the same features from lock to lock. For example, in this lock, we can see, just like Medico had the hardened steel crescent in the front of the shell, again, we're going to see that in this lock and many other locks. The hardened steel pins in the front of the plug, again, we saw those in Medico, and we're going to see those in this lock and other locks. As you learn about a new lock, I always think it's a good idea to try to remember how many of which components are in the lock. This is a 6-chamber lock, and so it's very common to us to have 6 chambers. We're going to have 6 bottom pins and 6 top pins, and then if we have master pins, whatever is added as additional master pins. We have the 6 springs, the spring cover, and then the other component that is loose in the lock would be the crescent, the hardened steel crescent in the front of the shell. But it's typically about the same number of components that you would see in a standard conventional lock. It's just a little different design of those components. We're going to take one of these locks apart and we'll see all of these parts in just a minute. In this lock, with the interlocking pins, when you turn the plug, the tails on the pins, the interlocking part, is still down below the shear line. And of course, for that to work, you have to have some type of exception in the plug that's going to allow space for that. And we'll take this apart in just a minute, and you'll see that there's grooves that are placed into the plug to allow room for the tail pieces on the pins. But if you want to turn it around more than 180 degrees, as it comes around and the bottom of the key is now up towards the pin stacks, it would stop there. It would not go any further. It would hit those tail pieces unless you had the cuts in the key so it could go right by the tail pieces. So that's what's happening with this. You have the regular top cuts are cut at angles, and just like in the Medico, they're going to lift and turn the pins So you have the top cuts cut at angles to turn the pins, and then you have the cuts on the bottom of the key to allow the key to rotate more than 180 degrees, and then you have to have the notches in the plug to allow for the tail pieces on the pins. So again, this is just a standard mortise cylinder. Okay, now I'm taking the tail piece off so I could put the key in, rotate it, get a follower, and go to push the plug out if it were a normal lock. But it's not going to come out. I can push on this all day, it will never come out. And the reason again is because of the tail pieces that are sticking down into the grooves on the plug. The only way you can rekey this lock is through the top. You have to take the cap off, and I'll go ahead and I'll take the cap off and we'll see the interlocking pins, and we'll pull the plug out and you'll be able to see the grooves in the plug. So I'm going to go ahead and again just get something pretty sharp, small screwdriver or pick or whatever you need to get a hold of that cap and move it back. Now, if sometimes they get crimped a little bit, and if it's been crimped a little bit, we may have to actually pry the thing up to get it out of here, and then put in a new top cap on it. But if it'll slide back, it'd make it a lot easier. Okay, I had to put this in the vise and use a tiny little chisel. Actually, it's a little bitty screwdriver I have. I use for a chisel to get this thing, this plate started up, this spring plate. And I want to go ahead and take it off. Again, this is a used lock. I'm not exactly sure what we're going to find in it. This cap is on here really good. I'm going to try to take it off carefully so we don't lose any of the springs out or the parts, so we can see exactly what the makeup of it is at this time. I'm going to go ahead and take that spring out. That was a spring out of number 6 chamber. There's number 5 spring just popped up. Take it out. Okay, there we go. Okay, there's the top pin. That's the number 1 chamber bottom pin. I'll get them all out here and then we'll look at them. Okay, let's see if that'll do it. Well, the plug's out. Okay, there we go. There we got it. Okay, so number 6, top pin, number 6, bottom pin. Now, you can see the grooves that are cut into the plug. And again, this is for the top pins that have this little kind of this T portion sticking out like the leg on a T. It rides in that groove. Again, when the plug is turning, that piece is riding in that groove like that. And if the grooves weren't there, of course, the plug's not going to turn, because this would be sticking down into the inside of the plug and prevent it from turning. Now, another feature of this, this is UL listed as high security, and it is drill resistant. It has the hardened steel pins in the front of the plug to help make it more drill resistant, just like we saw in the Medico. It has the steel crescent that fits up inside the cylinder, just like the Medico did. Now, to If you wanted to rekey this, again, you'd have to be able to cut the angles at 20 degrees, and you'd also have to, of course, have the correct pins to make this work. Just like any other lock, I like to load my bottom pins in so I can see that they're nice and flush. And again, these pins do have the beveled edge. You can see the slot. Notice the slot in the top of the bottom pin. So if you tap on that a little bit, it should go down and be flush with the top of the plug, and the slot should be in line with the groove around the plug. So watch for both things, that it is flush and that the groove lines up right. Now see that's not lining up right. Now they won't line up right unless there's a little bit of pressure on them, but if you tap them down, they should line up right. Let's dump that one back out. I don't see anything wrong with it. Unless as I was putting them over there, I accidentally got one in the wrong spot. Let's go ahead and put the rest of them in. This should be the number 4. And it's not. I just wonder if I got 3 and 4 turned around there. Let's take a look and see here. It's number 3. Okay, number 3, you can see is lined up correctly. It's number 2. You can see number 2 lines up correctly. And so I'm betting I got those, I picked up the wrong one as I grabbed that a second ago. And so you can see that this lock's not going to work like this. We can put it together and we have to take it back apart. So let's get that. This is the one that was in number 5, and it should be number 4. And then I'm going to take number 4 and just go ahead and pop it into number 5 and see if it'll line up right. There it is, see? So that's what happens. You know, I'm trying to explain this as I'm putting it together and I just grabbed the wrong one. So now they're all nice and flush, and the grooves are all just like they're supposed to be, in line with the groove in the pin is in line with the groove in the plug. So we can go ahead and we can put this back in. And just like with the Mul-T-Lock, don't forget your hardened steel crescent. And again, just turn the lock cylinder upside down, get it, and just kind of drop it into the slot, and then just give it a little tap until it turns around to where it's just like it's supposed to be. Then we can take the plug, push the plug in, we can turn the lock cylinder around, and there we have it. Now let's go ahead and I'm going to just go ahead and put the tail piece on it just to make sure that while I'm doing this I don't have any problems. Okay, so I'm going to go ahead and drop the top pins in. I'm trying to get away from this. Just make sure that the little tail piece is turned down. That was the number 3 one. Number 4. Number 5. And then number 6. Number 6 chamber has a little bit of an issue. We saw that it didn't want to come out and it doesn't really want to go back in. Anyway, it's in there, and I'd recommend taking a spring and put a spring on top and just see if it'll turn. Now you may have to take with this lock, to get these all set right the first time in particular, you may have to like run the key in and out. And I would do that a number of times. When you first put it together, just run it in there a number of times, back and forth, to make sure that all those pins are set before you turn it too far. Just turn it a tiny bit. Okay, well, we know that works. Don't go too far with that. I have had these, for whatever reason, to where if I didn't do that, I've had cases where I had to take the lock back apart. One of the top pins, for whatever reason, would just simply not go and seat in its little slot. Okay, so there I got 2 pins working there. Okay, now I got springs in 4, 5, and 6. Now see, this one did not want to work. I had to run the key in 3 or 4 times to get that to start working. It still doesn't really want to work here with these 3. So we may need to, and of course you want to put some lube on this, some good quality high security type lock lubricant. There it goes. It seems to be working now. But it's got to be lubed well for all those pins to turn like they're supposed to. Okay, so here's 4 pins now. Okay, I saw those 4 work. And now 5 and 6 are left. There's 5. 5 is working, and then 6. Okay, it's working. Now again, we could straighten this plate out here, and if we didn't have anything else and we had to do it, we could straighten this plate out. If you're out there at night and you just need to get a door locked up overnight, and then if it doesn't go on perfect, go back the next day. As soon as you can get the right plate, the spring plate, go back and put that on there. But my recommendation is always to go with a new top plate, new spring plate. I'm going to go ahead and show you how to use that old plate if it's possible. You want to get something hard and flat like an anvil, or on the back of the vise. It's usually a small anvil, and you can flatten it out a little bit, or you can put it into a vise and press it and get it pretty flat like that. And then once you've done that, take the end that's going to go into the lock. It's rounded on one end, and it goes in so that the rounded end goes in first. And then the other end, leave it sticking out a little bit, I found that this works the best, so that it's about halfway down and a little tiny part is still sticking out. And then get yourself a small mallet and just tap this over. Just bend it very, very slightly. And by doing that, of course, it's going to make the outside diameter going straight across to be a little bit smaller, and it's going to allow it to go into the lock easier. And the reason I don't do the whole thing is by the time I get the back part in, I want that really, really snug as it goes into the lock. So I've already done that. To start putting your spring plate back on, remember that you put a little bend in the plate, and you want the little high part or the bent part up. So you have to push the spring down and get the plate to slide in the slot over it, like so. And get your next spring. Same procedure, push it down, slide the spring plate up over it. If you have to give it a little tap with a mallet, you know you're getting a good fit. And just proceed on like that until you get all 6 springs back in there. Here's the last one. Go ahead and tap the plate on the rest of the way on. Like that. Got it back on there. And then what you want to do, remember we put that little bend in that plate, and we want to take that bend back out of there. One thing I'll do is I'll take an Allen wrench and lay it right in the center of the spring plate and give it a good wrap down. You can take a punch if you need to. If you still think there's a little high spot, punch it down. Punch in the center. It's going to make it spread out wider by doing that. So that's, again, not my recommendation, but I know as a new locksmith, it's hard to get everything you need in your van ready to go so that you're ready for every possible situation out there. So, again, this is not going to come off. This spring plate is in here solid. But had it been more manual or tore or whatever, I had a concern about it, I would have came back the next day with the new spring plate and just changed it out. It would have just taken a few minutes, but the customer's paying for a high security lock, and they're paying you to make sure it works proper, so that's what I would have done. But you can see here, now again, when you take the key out, make sure that when you put it in, it doesn't feel like anything is really locking up, that it goes in smooth, and you can see that it works perfect. Now, as I was putting the pins back in here, I put the bottom pins in, and I put the plug in, and then I dropped in the top pins, and then I ran the key back and forth with the spring on top until I was sure that the top and bottom pin had interlocked. The manufacturer actually recommends that you interlock the pins together, the top and bottom pin, and put them into the chamber as a unit. I have found that trying to do that, the best way to do it would be to hold the lock horizontally and push them in a horizontal position, and then turn it up, and it will fall down and pretty much stay locked together. But I have found that doing that, sometimes they will separate. And so even if you put them in as a unit, the best thing to do is, as I showed you, take the key and work the key back and forth until you're sure that the pins are locked together. One of the problems with this lock is that these pins can come apart if you push the key in or pull it out very quickly. And that's caused lockouts as the pins have separated and didn't want to go back into their proper alignment. So that is one of the complaints that we have had with this particular type of lock. The next lock we're going to look at is by Mul-T-Lock. Mul-T-Lock is an Israeli-based company which today is also a component of the Assa Abloy company. Mul-T-Lock is a very large company with a great many locks, and we're not going to be able to cover all of those, but we're going to cover the basic cylinder designs. The company is most famous for its use of a horizontal dimple-style key that uses telescoping pins, or what is known as a pin within a pin. The basic cylinder platforms offered by Mul-T-Lock include what's known as a 7x7. It's a 7-chambered lock. It does not include telescoping pins in the lock. And then an upgrade of this lock is the integrator, where one of the pins was replaced with a specially designed pin. Again, there's no telescoping pins in the integrator lock. The classic lock, which is a 5-chamber lock, does use the telescoping pins. Up from the classic lock is the interactive and the interactive plus. Both use the telescoping pins plus some other features, and then the MT5 and the MT5 plus, again with the telescoping pins and some additional features. So what I would like to do is get started right away looking at the telescoping pins. So I want to take a quick look at the classic. And we're going to just look at a couple of diagrams to explain the features and the terminology. And then we will take apart one of the interactive plus locks, and we can actually see the components and how they fit together. And then we will take apart one of the MT5 plus locks. The difference between the MT5 and the MT5 Plus, the 5 Plus has a sidebar in it, and it's identical to the MT5 with the addition of the sidebar. So we'll go ahead and look at the MT5 Plus, and that way we can see basically the same thing that's in the MT5 also. So just to review this one more time so we don't lose anybody as we go through the video, we're going to start looking at the Mul-T-Lock Classic. The Classic, again, was the first lock to use the telescoping pins. And then we'll look at the Interactive and Interactive Plus, and then the MT5 and the MT5 Plus. And then we'll come back and look at the 7x7 and then the integrator. So that's the order that you will see these locks appear within the course. Here's a graphic from the Mul-T-Lock website that shows their different platforms going from the 7x7 up through the MT5 Plus. Also shows the integration of the click technology at the interactive and the MT5 levels. Be aware that you need to get their manual, their service manual for Mul-T-Lock, because there are quite a few different types and different features to their different models. The original Mul-T-Lock telescoping design was patented in 1977. The original lock is referred to as the Classic. It is a dimple-style lock with telescoping pins. Notice that the keyways have wards, and you'll find wards in different locations. They could be on the, here we have one on the left, bottom, top, right. You can also have them on the sides, and there has to be a groove in the side of the key to bypass the ward. Sometimes the wards are deep inside the lock, and you cannot observe them as easily as you can with this particular Classic lock that we're looking at right here. But to get started, for people that are totally new, we need to probably look at the terminology here and again see, okay, what are the differences? What is special about these locks? And I'm using a service manual from Mul-T-Lock to look at the diagrams and get the terminology down as far as the components. The main difference and the thing that is really famous about Mul-T-Lock is they have a telescoping pin, or what's referred to as a pin within a pin. So instead of just one bottom pin in each chamber, there'll be two bottom pins in each chamber, and the same will be true for the top pins. Now the bottom pins they refer to as plug pins, and so you have an external plug pin and then an internal plug pin, and the top pins they refer to as body pins, and again you're going to have an external body pin and then an internal body pin. There's also going to be a small spring in there that provides spring pressure on the internal body pin, and then you're going to have a normal set of springs at the top of the springs at the top of the pin stacks. So those are the components, and if you just think about the number of them, with a 5-chambered lock, you're going to have 10 bottom pins, 10 drivers. There'll be a total of 10 springs that make the lock function like it functions. Here's a close-up of the lower pins, the external pin, and then the internal pin. Notice that the one end, which would go down towards the key, is rounded more than the top. Same with the internal pin, and then the internal pin has this lip around the top. This is a top pin, or what they refer to as a body pin. The spring is inside here pushing down the internal pin. As for the driver pins, Mul-T-Lock uses a number of different drivers, and you can see spooled pins, serrated pins, or you might even see a mushroom pin or an inverse mushroom, as you see here. Okay, your basic external pins are in 4 sizes, A, B, C, or D, and your internal pins can be in one of 5 different sizes, 5 being the longest. The pins are made of nickel silver, and the springs they use in the locks are stainless steel. So the locks have good wearability. There are 3 different styles of master pins used in the Classic and the Interactive. This solid pin here provides master keying for both the exterior and the interior pin. This master pin here is hollow and would provide master keying only for the exterior pin. This would be an internal master pin, and it would not affect the external pin. This is a diagram for a typical Mul-T-Lock key. We can see the dimples for where the location of the pins are at. And there's a larger dimple, and then there'll be a little protrusion inside of that works the inner pin. The tip of the key is the stop. The typical numbering as far as the cuts is from bow to tip, 1 through 5 in this case. The distance from the tip of the key to the number 5 cut is 5.3 millimeters. And then they're centered at 4.8 millimeters to the additional cuts. Mul-T-Lock keys are divided into 2 major groups according to their profile of either left hand or right hand. The lock that we're going to be looking at today will be a right hand lock, and you can see that if you lay the key with the tip away from you, that the cuts are on the right side of the key. If it's a left hand key, the cuts will be towards the left. You can see with the key that we're using in our example today, it'll be a right hand key as the cuts are here. If I turn it over, the cuts are still here on the right side. This diagram shows one of the cuts with the, if you go from outside to outside, that would support the larger of the pins, and the protrusion in the middle would support the inside pin or the internal pin. So a close-up of a key. You see the dimples cut into the key. Notice that there's the larger cut for the external pin, and then in the center will be a cut for the internal pin. You may come across multi-locks that have dimples cut into the side of the key, as some of their locks do use actual side pin. Now here's an example of pins that are on the worked by the side of the key or the edge of the key. In this picture we can just barely see the top pins up here, and then these pins are on the side of the plug and worked by the dimples in the edge of the key. The next lock that we're going to look at, and we're going to spend some time with this lock, is the Mul-T-Lock Interactive. And we're going to go through again, just like we did with the last high security lock. We're going to go through here and what are the differences, what are the components, how does it work. The locks do come with cards with magnetic strips that have the information for the key. These keys are patented, and so you have patent protection for the key, and to get one made, of course, you'll need identification. You'll need the information on the card. And this lock has a new feature. It has a floating disc actually that's embedded into the key, and there's also a pin embedded in the plug. And with the interactive category of locks, they added a new external pin and a new internal pin. So they added the Z pin to the other pins that they had, the A, B, C, and D external pins, and they added the 0 pin to the internal pins. So there's a total now, with the interactive series, there are 5 externals and 6 internals. And as they progressed with the development of more locks, more pins have been added. So mostly the new pins have been in the master pin category, but like I say, they're developing new locks all the time, and so you have to just really keep on top of what's coming with each new series of locks. Now, if you're not used to working with this type of lock with this horizontal keyway, it's easy to get confused as to where your top pins are going to be at. And of course, they're going to be right in line with the chambers right here. But once you turn the key, you want to remember that, so that you can get that plug out without dropping your pins. Usually makes it easier anyway, unless you're going to take them all out anyway. But just put your key in like normal, push it to the back of the plug so it's flush with the back of the plug, then the lock will turn. I just bring it around with this mortise cylinder, this type. I just bring it around 180 degrees, take your follower and just push it out just like any other lock. Now here you can see I got the pins pushed up a little bit. The key's not quite lined up right, and you can see that as I get it in there just into the right spot, they'll drop down right there. Of course, there's no spring pressure on them, so you have to tap them down a little bit, but that's it. And then we'll take those out and look at them. See, here's both your external and your internal, what they refer to as the plug pins or the lower pins. And you can dump that internal pin out. And when you put it in, if it drops down through like that, you know it's in the right way. If you put it in backwards, it won't drop down through there. See that it won't come down through if it's in backwards. So if you put a pin in there, the internal pin doesn't drop down through the external pin, then you know it's in backwards. This is the number 2 pin, and I'm not going to take all of them out. If you see one of them, basically you know what I'm talking about. But this is the interactive part here, and this is again, it's the same idea with the telescoping pin, but it does line up on the interactive pin that's in the plug, so I will show you that. If you look, I'm going to put some light on that. If you look right in there in the bottom of that chamber, in the second hole in the plug, you can see the interactive pin. If I turn it over, you can see it right there. Now watch, if I turn it back, it'll come out. It's just free floating in there right now. Of course, once it's back in the lock, you know, with the spring pressure on it, then it would push it down into a small hole in the bottom of the lock cylinder. So that's the floating pin. Okay, let's look at the key for just a minute. They do have both right hand and left hand keys, and they have really quite a variation of keys, but the ones we're looking at today with the interactive lock, they have right and left hand keys. But Mul-T-Lock is a very large company with many locks, so you're going to see many variations of their keys. But with this particular key, they have right and left hand. If you hold it so the tip is away from you, and the cuts are on the right, it's a right hand key. It doesn't matter if I turn it over. You can see the cuts are still on the right. So it's a convenience key. It can be put in either way. Now, one of the benefits of this key is that you can have different cuts on the two sides. It doesn't have to be a convenience key. In other words, you could have one side cut for one set of locks and the other side cut for a different set of locks. And that's real handy if you have two sets of locks in some facility, say for example in an apartment complex where you have the front door and the laundry room and the pool area. Maybe there's a vending room or something like that, and you want one lock for that all of the tenants can access. One side of the key could be cut for those common areas, and then the other side could be cut just for the individual apartments in the complex. So there are a number of advantages to that type of key. Now with the interactive key, it has this floating disc, and it's right here, and it's on both sides. And just when the key is free like this, it just floats. And the one on the other side is dropped down. If I turn it around real slow, you'll be able to see it sticking out a little bit. If I continue to turn it on around, it'll drop back into the key. And then the one on the other side will come out. So you can see that it came out here. In this lock, this lines up with the second cut. This is 1, 2, 3, 4, 5. It'll always be in the first or second position, but in this lock it's in the second position. Let's go ahead and pull one of the top pins out. You can take them out just like you do any other lock, and then we'll get the spring out. Okay, here's the body pin for the first chamber, and you can see the little inner pin sticking out. If I push on it, you see I can push it back up in there, but the spring is inside the pin there, so it pushes it back down. If we can look inside this lock cylinder, you can see that there's a little cut here for that interactive pin. There'll be two, one lined up with the first chamber and one lined up with the second chamber. And so when the plug is back in the lock and you have spring pressure on that either first or second chamber, is going to push that floating pin that's in the plug down, and the point will have a place to go into the cylinder right there. And then as you put the key in, it takes the pressure off of that pin, and it's going to allow it to turn. To reassemble one of the locks, it's just like any other one. Just grab your springs and put them in just like you would a normal lock cylinder. Grab your top pins. Push them down. Put some pressure on them from the plug. Get a hold of them, push them down in there. Just like that. Putting the pins back in. This is the number 1 pin. We see the internal pin sticking down like it's supposed to. Goes right there. This is the pin for our number 2 spot. We just drop him in there. And it's always a good idea to take your key, just like any other lock, and put it in there, and just before you put it together, just double check it. Again, make sure that the key's lined up with the end of the plug, and give them a little tap to make sure they're down, and they all look pretty flush. The key moved in and pushed that out then. But they're all in there and they're flush. Take your lock cylinder, put it back in, bring it around, let the pins lock in position. It's back together. Get the tailpiece back on it, then check it. Make sure it's working okay, and you can see that it is. 3 key kits for Mul-T-Lock are kind of expensive. They do make a mini kit, which is what this is. And it has the basic pins for the interactive lock. It's got the 5 external pins and the 5 internal pins, and it comes with a plug follower. To measure the pins, you're going to need a pin gauge like this one. So that should come with a pin kit if you order a pin kit, Mul-T-Lock kit, but make sure when you order the kit that it will come with a pin gauge. And if it doesn't come with the gauge, you're going to need to get a hold of one in some way if you want to be able to measure the pins and determine what size they are. The way it works, you can see they have the different letters here, and there's a space. Like, for example, this number 4, the pin, number 4 pin would fit right in here, or the D, the C+, DD, D-, those pins would fit here, depending on which locks and which pins you're working with. But take a number 4 pin, and I'll show you that if I put it here on the number 3 gauge, it will not go in there. For example, you just line the pin up with the gap on the card and see where it fits. So you can see that number 3, this pin will not fit in this number 3 slot. It's a number 4 pin. Now it fits perfectly. So it's best to start from the smaller ones and go to the bigger ones, just to make sure you don't put it in one that's too big, because there's not much difference. If I put it in the number 5 and you don't get the card just right, you may think that fits, but it doesn't go there. This is because it does fit in the number 4, so it is a number 4 pin. So that's how you use the pin gauge. It also has measurements on the other side for master pins. The next lock that I would like to look at is what's called the MT5 Plus. Mul-T-Lock has both the MT5 and the MT5 Plus. The MT5 Plus has the additional feature of the sidebar, so we're going to go ahead and work with that particular lock so you can see how the sidebar works. Just know that the MT5 is basically identical, except it does not have the sidebar. The main differences about the MT5 locks are, in addition to the key has a little spring up here in the top that works the last chamber. In this case, it'd be the 6th chamber in the lock. And it simply, as it goes into the plug, it simply is pushed up to push the pin up. The spring is referred to as an alpha spring, and the pin that it pushes up is referred to as the alpha pin, and it is also a special design. And again, we're going to take this lock apart and we'll see all of these components and how the key works. But as far as the differences, this lock compared to the classic lock, the main difference for the MT5 would be the alpha spring and the alpha pin. And then if we have an MT5 Plus, then we have really a whole different lock. We have a sidebar in there, and we have 5 additional pins that are going to work the sidebar. Here's a cutaway view of the alpha spring, and you can see that now it's pushed up towards the top in this picture. And what happens is, as the key goes in, the plug is designed so that it's going to bump the spring up to push the alpha pin up to the shear line. Here's the alpha spring here. It's very small. I'm real close to the camera so you can get a good view of that. And I'm pushing it from the other side so I can get it to pop up so you can see it there. Looking at the diagram here, this is from the Mul-T-Lock website. We can see again, now in this lock there will be 6 chambers. You're going to have your telescoping pins for 5 chambers, then the addition of the 6th chamber where the alpha pin is at. The alpha pin also has a special driver. So that now we have the telescoping pins. We have the 10 lower telescoping pins, the 10 upper pins, the springs, and then we have the addition of the alpha pin, and the alpha pin has its own driver. In addition to that, you'll see these pins are called finger pins. There's a little finger on each one. And so the number of components here has greatly increased. With the telescoping pin, you really have quite a few more parts. So if we were to do a component count on this particular lock, the parts that are actually inside the shell, we would see we had 5 finger pins, 10 plug pins, 10 body pins. Then in addition we have the alpha pin and the alpha driver, and then we have our normal pin stack springs. The MT5 and the MT5 Plus pins are smaller in diameter, and they have slightly different designs compared to the classic locks. Okay, now on this alpha pin, Again, it looks like there's two parts joined together, and the smaller part sticks down below the big part. That goes down towards the key. And the key, that's the part the key touches, and it'll push, of course, the whole thing up to where it's even with the shear line. This is a close-up of the plug that the alpha pin would go into. And you can see that it's not hollow all the way through. It's a totally different design than the other chambers. This is the driver from the MT5 Plus. Again, it is spring-loaded with the inner pin in there, just like we saw in the interactive lock. Now these normally stay together. The spring and the inner pin are self-contained in there. You don't normally have a problem with those coming apart and losing parts there, but I point this out that there is supposed to be spring pressure on that, and if you have a problem with some lock, you want to check all of the springs to make sure that everything is working properly inside the lock. Notice that the finger pins are on the bottom part of the plug and that they are perpendicular to the other pins. And we'll look at this more in just a minute. We'll take this lock apart and we'll look at this, but this is what you're going to see. The groove on the key here is what works the finger pins. So this is not the groove that would be working these pins. It would be on the bottom of the key. When the pins are in the lock, the fingers are lined up more or less underneath the regular pins, so that this part of this key would work the telescoping pins, and then on the other side of the key would be a groove just like this that would be working the finger pins. Here you can see the additional bitting that was added to the key in order to operate the pins that allow the sidebar to function. When I remove the plug out of the Mul-T-Lock, this MT5, I just turn the plug a little bit. Because there's so many parts in it, I want to just be able to keep track of where all the parts are at. And if I turn it too far, I may think I have my finger underneath the sidebar, or I've got a finger over the ball bearing, and I miss that part and it falls out and rolls off somewhere and it's gone. So that's the way I do it, and that's my recommendation, is just to turn it a small amount and bring the plug out. The sidebar's got two little springs under it that we could lose, and then the ball bearing on this side. So we want to watch for those components as we push the plug out. Okay, so I've got my finger under the sidebar, and I'm going to go ahead and turn it a little bit so that the ball bearing will be up, and hopefully we won't have to worry about it. Okay, so we can see our ball bearing is here. We see our telescoping pins. This last one is the alpha pin, and I'm going to take this apart. And in fact, I want to do an exercise. I'm going to just dump all the parts of this lock out, because I want you to see a scenario where that happens, because it can happen very easily that you pull the plug out and you forget this or you forget that, and you have parts just everywhere. How are you going to get that lock reassembled? So I want to do an exercise like that, and I want to just show you first the sidebar on the back here that I was holding. It has two springs under it, and it is worked by again, finger pins. Okay, so I want to turn this around so we can see the finger pins, but again, if the sidebar comes up, we need to be ready to catch the sidebar, and we have to watch out for the ball bearing. But here are the finger pins here. There's 5 of those. And there's no springs under those, and they don't fall out real easily, but they will fall out, but they do have little grooves that they slide into. It does help hold them. And of course, we have in the shell, we have our pin stacks. We have our springs and our driver pins that are still in this part here. And I'm going to take this apart, and like I said, I'm going to just take it completely apart, take all the pieces out, dump them into a little bin, and we're going to sort them out and figure out which ones go where. Okay, these are the finger pins here, and if I turn it, I can show you the top pins on the top. So notice that the finger pins are on the bottom part of the plug, and they are perpendicular to the regular pin stack. As I move the key out, you'll see the finger pins go up and down, and then as I put the key in, you can see them move as the groove in the key is adjusting them to the correct position for the sidebar. So if I bring it back far enough here, we can see the groove here working the pins, the finger pins. And again, this is on the opposite side of the key from what is working the regular pin stacks, the telescoping pins. So both sides of the key are working when you have the sidebar in the lock. Okay, so let's say we have an accident and we accidentally get the plug out and the pins fall out and they're just dumped all over. Just sort them out into your inner pins, your exterior pins, your drivers, your springs, of course. There is a special driver for the alpha pin, and then the alpha pin itself is very unique. So just go in and sort them out by groups, exterior pins, interior pins, and then drivers. Put the alpha pin aside, get the springs out. And that's what I'm going to do with this here. I'm going to go ahead and just separate it all out, and we will figure out what goes where, and we will build the lock back. This MT5 cylinder, if you put your key in there with no pins and anything in the plug, that alpha spring can catch on different parts of the plug and may not want to come back out. Just take a pick or something, and I can see it. You're not going to be able to see it on the camera. I'm sure it's too small and it's too far in the plug, but it's catching right there. You can just make it out a little bit on the camera. Just reach in there and push it down a little bit, and then if it catches again, just go to the next one and keep doing that until your key comes out. It's like so. Here we have for the sidebar, you have a spring on each end of the sidebar, just like we saw with the Medico. There you can see a close-up of the sidebar. The sidebar has very thin, almost knife-like blades here in these 5 slots that must enter into a slot in the finger pins. So the milling in the key has to move those pins to the correct position to accept this sidebar. Here's a close-up of one of the finger pins. You can see the finger sticking out, and you can see the slot that engages the sidebar. This is a close-up picture of one of the finger pins. These are actually referred to as sliders. I tend to call them finger pins, as there's a number of high security locks that use a similar pin that has a little finger on it, and just commonly they're referred to as finger pins. In the Mul-T-Lock, they do refer to them as sliders. Now, if you study the groove in the key, the finger pins do mark the groove, and you can see where they are situated at, where it's like a dual set of marks. The number 1 pin here, counting from bow to tip, the number 1 pin would be here. The number 2 pin is here, number 3 is here, number 4 is here, and then number 5 is right here. There's 5 finger pins. Okay, I've taken out the number 1 and number 2 chambered finger pins. Notice the groove in the number 1 is much closer to the finger on the pin than is the groove in the number 2 chamber. So to get those lined up, the number 1 pin has to be pushed a little bit higher than the number 2 chamber pin. So you can look at those, and once you kind of get the hang of that, it's pretty easy to tell which one you're going to need in which chamber. So you can see here I have all of the exterior pins in this one group, and if we were to simply take them and line them up from the tallest to the shortest, again, I'll just lay the key here. This is the deepest slot is going to be the longest pin, and that's it right there. I'm going to go ahead and move it over here. I'm going to go ahead and put these back. These 4 got jumped around on me there, but you can see that this pin on the end here is a little bigger, and it's going to go to the number 3 slot right here. So I'm going to just move it up here. That is the number 3 slot. Then we have the next is going to go on the number 5. That's this one. It's the next. If I line them all up here, you can see that these 2 are the same, and this one here is a little longer. So it's going to go over to the number 5, and then these are going to be 2 and 4, and they are the same. One thing we could always do to measure the pins is grab a dial caliper, and we could measure the diameter of each one of the dimples and calculate the size of the dimple, and from that we could determine what size pin would go into that particular location. So there are a number of ways to go about getting the exact measurements, but it's more time consuming than the method that I showed you. If you're sure you have the right pins that came out of the lock, the way I showed you basically was the fastest way to put them back in there. But just remember that the bigger the dimple, the longer the pin. Okay, now we can check to see if we're right by dropping the pins into the chambers. So this was the first one, and see if it's flush. Remember to make sure the key doesn't come past the end of the plug and all of the little dimples are lined up properly. This would be number 2. We can see that it's flush. This is number 3. We can see that it's flush. Then number 4. And it's flush. And then number 5. And it's flush. Now to read the inner pins is a little more difficult, but you can see that this 1, 3, and 5 dimples are much deeper than 2 and 4. And the little inner part of the dimple that raises the inner pin is very difficult to see, but we can see how deep 1 is. We know that this inner pin is going to have to be much longer than the inner pin for number 2 that has almost no dimple at all. Even though we can't really get a real strong reading on the little tiny part in the middle of the dimple, we know that this one is longer. Same thing we could see on number 3. If the little part in number 3 was real long, if it stuck up to where it was close to number 2, I mean, we would be able to see that, but we can tell that it is not sticking up anywhere at all like that. So we know that, first off, what I'm saying is we know that the inner pins are probably going to be close in length to the outer pins. And so we can just use that as a guideline to begin to sort them out and make the trial and error process of getting the right pin in the right place a little easier. So I've lined up our inner pins here. And it's obvious that these first two are longer. And since number 1 was our deepest dimple, we're going to match that one to number 1 to start with. Number 3 was our next deepest dimple. And we can see that this is the next longest pin. Actually, this one and this last one are about the same. So those two pins look identical. So one of those probably goes to number 3, and one of those probably goes to number 5, because number 5 was our next deepest. And then we have two that are the same again, but shorter, and we're going to match those to number 2 and number 4. So let's put the lock together with the pins arranged like that and just see if it works. Okay, I put the inner pins in. We have the exterior and the inner pins in, and they are exactly flush in the order that I had them laid out. Now, if they were not flush, if two of them were turned around, you would see it here, and you would simply just swap those two around. But like I say, if you match the shorter inner pins to the shorter exterior pins, it normally works out pretty close. And if it doesn't, it's just a matter of trial and error to get the right ones. And again, the other scenario would be to measure all of the pins and try to calculate the distance from the dimple to the shear line and see if you could do that. But this is really the simplest way to do it. Okay, so I'm going to go ahead and drop the alpha pin in, and we'll have all of these ready to go. So our standard or our conventional stack with the telescoping pins and the alpha pin are all back in the plug with the key in there. Remember to keep the key flush with the end of the plug, and everything should be flush on the top. Okay, the next step for us to do is to sort out our finger pins here that work the sidebar. So I have them all lined up here, and if you'll notice that the only difference in these pins is the location of this slot. That this slot in this pin is very close to the end of it. The slot's right here. This slot is further away. This slot is further away. So I'm going to line them up by the distance they are from the distance the slot is from the end of the pin. Okay, now I've lined the pins up in order by the distance the sidebar slot is from the end of the pin. This slot on this pin here is the one that is the closest to the end of the pin. This one is this slot is a little further away than what that one is, and then the last three here are identical. The slots are the same distance from the end of the pin. So what that means is that this pin number 2 here, the way I have them laid out right now, this pin would have to be raised a tiny bit more than these 3 pins in order to get the slots all even. And then this first pin's got to be raised even slightly more than the second one for its slot to be even, so that all 5 slots are even and the sidebar can go into it. Okay, now looking at the milling on the edge of the key, we see 2 locations where the milling is different. And so that this one is going to be raised the most, this one the next most, and these other 3 are going to be the same. So the way they're laid out here on the table, this one here has to be raised the most. It's going to go into this position right here, which is the number 1 slot. There's five chambers for the finger pins. So that would be the number 1. And then we can see, if you look closely on this key, you can see these little marks here that indicate the 2nd chamber and the 3rd chamber. This is the 4th chamber, and this is the 5th chamber. So that The number 2 pin will go into the 4th chamber of the finger pin. So I'm going to just move it down. And so this would be going from this direction here, 1, 2, 3, 4, 5, and that should line up for the sidebar to work. Now it's not always that simple, but this milling on this key is pretty simple. But you would use the same process. Is the quickest way that I have found is if you do drop your pins, the quickest way to sort them back out is by doing this. These pins are flat on one side, and the ends are beveled. You can see it's beveled off. And there's no springs on these. The groove in the key and we'll take it to the correct distance for the sidebar to work. It doesn't need a spring. The groove in the key does all of the adjustments of the finger pins. So that this number 1 chamber lines up with this indentation here. And there's a little piece of the key here that's going to push it up into there, whereas this number 2 chamber is not going to get pushed up basically at all. It's going to just stay right on the edge of the groove there. And the other one that's going to get moved up is the number 4 chambered pin. Okay, I've started putting the finger pins back in the finger pin chambers. I have the first 2 in here. The third one I'm putting in now. The little finger on the pin goes in first. You drop that part in first, and there's little grooves that it has to line up with. And if you have the grooves lined up, it just falls right in there. This is number 4. And then number 5. We're going to go ahead and put the key in, and it should bring all of the finger pin slots to the correct position for the sidebar to go into. But you'll notice that differences in the heights of the finger pins here. If we look over here, all of the slots should be lined up right in the middle of this. This is going to be difficult to capture on the camera. If I take it out and slide it back in, you can see the finger pins moving as the key is catching them. See, as it's out, and again, this is a very small groove here that this goes in, so it's going to be difficult to see it. There's no slots lined up for the sidebar to fit into, to recess into the plug. With the key in there, they're lined up. And if we take our sidebar, and of course we have to put our springs in, but I'm going to just put the sidebar in to show that it will go in and drop all the way in. There's nothing in the way of the sidebar dropping in. So we know all of the pins are in the right position. So I'm going to just turn that over and drop the sidebar back out. Now this is a close-up of what the inside of the plug looks like. And you can see the fingers on the finger pins, and you can also see the telescoping pins. And the key, of course, has to work both. All of the pins will be positioned properly, if it is the correct key, for the sidebar to recess into the plug and for the plug to open, the plug to turn. This is a close-up of the sidebar slot where the sidebar would go, and you can see that all of the finger pins are lined up so that the gates are in the correct position for the sidebar to recess into. And just like with the Medico, before you put the plug back in, you want to make sure that the hardened steel crescent is in its proper position in the shell. Okay, so we're going to drop the springs back in. Okay, then we're going to put the sidebar in. Sometimes it's easier to get it with a little pair of tweezers and line it up. Push it down in there. And if the key's in the right position, it should go all the way in. Then we're going to turn it back so the telescoping pins are up. And then I'm going to take it out and I'm going to put my finger under the sidebar. And then we can go ahead and start it into the shell. Okay, now once I know that it's into the shell far enough to hold the sidebar, I grab the ball bearing and put it back where it goes. And then I continue pushing it the rest of the way in and get the pins locked into position. Like so. And put your tailpiece back on. Now when you put your cam back on, they do recommend that you use Loctite on this particular lock. Okay, so I have the screws back in there. Here's our key. See, that works fine. The 7x7 lock does not have the telescoping pins. It does use a mushroom pin for the drivers, but it's much like a conventional lock, except that it has 7 pins in it, 7 chambers. Still has a dimple style key. Following the 7x7 lock that came out, next introduced by Mul-T-Lock was what's called the integrator. And the integrator is a special pin that has a special cut in the key, which again makes it more difficult for people to try to duplicate these keys because it has something special in it. That's what they've done, is added another feature to make it even more difficult to cut these keys. But that's the difference between just a 7x7 and the integrator, is this extra special pin and then a special cut for that pin to work properly. Okay, now here's another diagram that shows the integrator pin, and in this particular plug it shows it in the first position. It is not always in the first position. Click technology, that's C-L-I-Q, click technology, was developed by the Assa Abloy group. The new technology is applied to their best cylinders manufactured by the group worldwide. This would include Medeco, Mul-T-Lock, the Assa Twin, and the Abloy Protect. Mul-T-Lock has embedded their innovative click technology into both of the patented mechanical platforms, the MT5 and the Interactive Plus. Click provides access control with time-restricted access and audit capabilities. The technology has been made possible by the miniaturization of many components, including computer chips and motors. A tiny motor within the plug actually moves a blocking element, which allows a sidebar-style pin to retract into the plug. The key blanks are protected by patents, and the electronic code is protected by a strong encryption. This combination provides high mechanical security as well as maximum electronic security. The blocking mechanism consists of a sidebar-like system, which is contained in the plug. I say it is a sidebar-like system. The actual locking pin is somewhat similar to the check pin used in the Schlage Everest. We will learn more about that lock in the next course. Click keys and locks do require special equipment in order to program them and retrieve the usage data. You can learn more about how this program works on the Mul-T-Lock website. This is basically the way the key works. The key is inserted into the cylinder. When the contact pin meets the contact strip, an electronic wake-up signal is subsequently generated. The cylinder awakens and generates a random 64-bit number. The key answers by transmitting an encrypted number. Fourth, the number is decrypted and compared to the response calculated by the cylinder's microprocessor. A log of the interaction is automatically stored in the cylinder's memory for retrieval. If there is a data match, the identification process will continue. If the data indicates the user is authorized to enter, the interactive mechanical element is cleared for activation. Here's a diagram that shows the basic components of the click system. You can see the plug and then all of the parts that are attached to the plug, and you can see that without them being very miniaturized, the program would not work. So that you have the electronics, you have the little pin, you have the tiny little motor that moves the blocking element out of the way so that the pin can retract into the plug, and the whole thing works basically on the power of the battery that is in the key. So that's how it works. Now, if you want to learn more about the click technology or just to keep up with the latest developments with Mul-T-Lock, I would suggest to simply go to the YouTube website and look up the Mul-T-Lock channel. They have over 30 videos demonstrating most of their products, and they have several good videos on here that show exactly how the click technology works. Other high security locks that you should know about include Medeco, which was covered in course number 18, Assa, Abloy, Schlage Primus, which we'll cover in number 20, and then Bi-Lock. We're now going to look at a few other high security locks, and I'm going to just use some pictures off of the manufacturer's websites to show the different features of these locks. Okay, now I want to show you another way to operate the sidebar. And the lock that we have here is a V10 or a twin V10 made by ASA. ASA is a Swedish lock manufacturer, and they first introduced a lock just like this, which was called the Twin 6000, way back in 1981. And there is a sidebar here, and it looks very similar to the sidebar that we saw in the Mul-T-Lock, where there are gaps in pins that the sidebar has to slide into. But notice that both of these, the conventional pin stack and then these other pins that operate the sidebar, both are vertical, whereas in Mul-T-Lock we saw that one set of pins was perpendicular and they operated their key horizontally. Notice the key here for ASA's key. They have two sets of cuts. They have a set of cuts on the top that operates the normal conventional pin stack, and then there's a set of cuts here on the side. It's called side milling, that will lift this other set of pins to the correct height for the sidebar to work properly. So again, this lock was introduced in 1981, which was called the 6000, the Twin 6000. This lock is a V10, was introduced in 1996. The original lock used a spool-shaped pin. The 6000 used a spool-shaped pin. The V10 went away from the spool-shaped pin. They introduced some new pins, and they also introduced some new profiles for their keyways so that they could pick up a new patent for their lock. So again, this is the ASA. A couple of other differences about the ASA locks: they number their cuts in the reverse. They go from tip to bow. And on their pin links are also reversed. The number 1 pin is the longest pin. The number 9 pin would be the shortest pin. So a couple of differences about the ASA lock. Here's a nice close-up on the front of the keyway, and we can see the 2 pin stacks. Again, the pins on the left are picked up with a little finger, normally referred to as finger pins, and then your conventional pin stack. Okay, this is an exploded view of the ASA Twin 6000. Shows the spool drivers, the bottom pins, springs on the top of the spool drivers. You can see your sidebar here, your sidebar pins, your side pins with their springs. Has drill resistant pins. On the key you can see the regular milling and the side milling for the sidebar. The ASA Twin 6000 and V10 both will fit many different varieties of locks, from the Euro profile lock to deadbolts to cam locks for all types of uses, key and knob locks, and so on. This is from the ASA website. The next lock I want to look at is much different from the other ones that we've seen so far. This lock is made by Abloy, which is a Finnish company. It's not a pin tumbler, but it uses these discs, and it actually works much like a safe combination. That, if you remember back in course 13, we looked at safe combination locks and how the wheels would turn and they would have gaps in them for a fence to fall into. This lock works the same way. You have all of these discs that have to be lined up with these so that the gaps are all in a row, and then the sidebar will drop into that gap and allow the plug to turn. So again, this is it's a much different design. It is a pretty popular lock. We actually see this same system in some automotive locks today. The keys are cut with angles. The angles are a little different from what we saw in the Medico lock, but the angles have to match each one of the discs. And if they don't match, they're not going to line the disc up correctly. When they first were introduced in the United States, they only went one direction. And then if you turned it the other way, it allowed the key to come out. But the newer ones that they've been selling, the disc can turn in both directions. Here's a later version of the lock called the Protec. They actually have the Protec 2 out today. Here's another picture of a key, and you can see the different angled cuts on here. There's a dimple in the key that when the key's pushed in all of the way, the dimple will line up to allow the key to turn properly. And with the V10, they actually added a second dimple to the key. Here's another close-up on the angled cuts on the key. Here's a close-up of an obloy padlock. You can see the keys here with the angled cuts on the key. And again, this particular lock is integrated into a great many locks that can be used for every possible use. Here you can see where the dimple lines up with a ball bearing. If the key is pushed all the way in, the proper key will line up. And another good picture of the disc here in this cutaway of this lock. This is from the Abloy website. This is cutaways showing the plug for the Protec 2. It has 10 discs in it. You can see the ball bearings here at the front. This is actually patented through 2031. Here you can see again, this is from the page on the website that shows the many different locks that the Abloy key and cylinder will work with. They have everything from padlocks to deadbolts to the European style lock, Euro profile lock, cam locks, and so on. Another company I'd like to look at here is Mul-T-Lock, which has been selling locks in North America since the mid-1980s. They're not real popular, but they are making headway, and they've been able to sell these locks into airports and casinos, hospitals, universities, and so on. And they are fairly good lock. They're very pick resistant. They're very bump resistant. They have a number of features here that we're going to go over. Their newest lock, of course, has added some features that make the lock even more difficult to pick or bump. So here we're looking at the Mul-T-Lock website, and you can very easily go on there. With Mul-T-Lock, when you do a search for Mul-T-Lock Australia, and I have found that provides the most information on their locks. And it has some similarities and again some differences. The similarities with the other locks, it is a pin style lock. Difference is there's 2 rows of pins. And these pins also operate the sidebar, and there's a sidebar on each side. The key is a U-shaped key, so that basically it's like inserting 2 keys at once, one to work one of the pin stacks and one the other side of the lock and the other pin stack. The newer generation of this lock has an additional pin and a component here that works this movable pin at the front of the lock. And these are features I'm sure that were added to get extended patent protection. And I believe that this patent is through 2019 on these particular components. Here's a little better close-up possibly of the bi-lock. And you can't really see in the detail of this diagram here, but these pins have holes in them. You'll notice that the components here with the sidebar, that the protrusions are round, and these components here simply slide into holes in the pins when the pins are lined up correctly. These protrusions here would be on the back of this sidebar here. Here you can see also this blocking bar that's moved out of the way on the new generation lock, but it's really a fairly simple concept once you understand it. And it's much like the Medico in that the protrusions on the sidebar simply line up with the bottom pins in the conventional stacks. The main difference, of course, is you have sidebar on both sides. Now again, this is a new generation lock, and the older locks are not going to have this lift pin, this faceplate, or this blocking bar. Other than that, they're basically identical. Part of their newest patent includes this component here, which they call a trigger. And as the key goes into the lock, this trigger mechanism pushes the pin up that is inside the plug. The components that are inside the plug they call a face insert and a lift pin and then a blocking bar. And when the key goes in, it moves all of these to the correct position for the plug to turn. This is referred to as the face insert, the lift pin, and the blocking pin. Here's the blocking pin here in the locked position, and basically what it does, it's one more component that's not going to allow the sidebar, which would be here. The sidebar cannot recess into the plug until this blocking pin is allowed to also recess into the plug. So here with the key inserted, what happens is the plug forces this trigger mechanism up. That pushes the lift pin up, and it drags this blocking bar out of the way of the sidebar. Now here's an illustration that shows an uncut key for bi-lock, and it just looks like this. They're cut on a punch machine, and then there's another machine that will fold the key so that it looks like this once it's folded, and then it will go into the lock like it's supposed to. Here you can see a key that's already been punched, and it hasn't been folded into a U yet, but it's been punched and now is ready to fold. This is a picture of the bi-lock punch machine that punches the cuts on the key. This is the machine that actually folds the key once it's ready. Again, from the bi-lock website, you can see that they advertised their lock to have many uses, from the rim style lock to padlock, mortise lock, and so on. Okay, there's one more high security lock I want to just tell you about very quickly, and that is the Pyramid Lock by Corbin Russwin. And I want to just toss it in here because it's different than the other ones that we've talked about. It has this locking plate on the bottom of the cylinder, and What it requires is there's a pin that's embedded in the key to push that down. And without that pin and that key, the plug will not turn. Other than that, it's pretty much a conventional lock with the standard bottom pins, top pins, springs, and so on. Has the hard and steel pins to get the 437 rating and all of that. But it does have that additional feature that I wanted to tell you about. So again, that's the pyramid made by Corbin Russwin. These drawings are from the website, the Corbin Russwin website. You can look these up. And again, here's another picture that shows the locking bar and the necessity to have the control pin, is what they call it, that's embedded in the key. Here's a close-up that shows the plug and the plate without the key, and it says locking pin mechanism engages blocking plate, prevents the plug from turning. And then here's a close-up with the key, and it says key control pin depresses the locking pin mechanism and allows the plug to turn, and it's illustrated here in the diagram. We have covered a great deal of material in this course. Most locksmiths tend to specialize in a certain brand of high security locks. My intent with this course is to give you a number of possibilities you may be interested in learning more about. I would suggest starting a file or a notebook for each of the locks covered. Try to obtain as much written material as possible for each one. Talk to your supplier to find out what is easily available in your area. Once you have decided which brands you want to work with, try to obtain those locks and study them. I would also like to suggest that you review each of these locks and compare their features. You may also find it useful to go to each of the respective manufacturers' websites for additional information about these locks and also see their latest technology. That concludes this video. We want to thank you for buying this video, and we hope you found it informative. Please visit our website at www.locksmithdvd.com and review our other courses.